Okay, so great. So now let's look at problem 4. While running the casino, an astute casino manager observed that out of 345 chips, 27 were found to be underweight. What percent of these chips were underweight? Now, of course, we're not going to ask how this casino manager found this out. We're just going to accept that this casino manager found out that these chips are underweight. This could be a serious concern because this could mean counterfeit chips and stuff like that. Okay? And that would be basically theft of the casino, and casinos don't want you to steal from them either by gaming the system or by outright theft, as this would be. Okay, so now we're going to look at this as a math problem, and we're going to set up what we need to do to set this up. They tell us that we have 345 total chips, 27 are underweight, and we want to know what percent of these chips were underweight. So we can see that in terms of our language that we just talked about, this is a percent problem because we're going to be searching for the percent. So now what we do is I start by listing what I'm given. Right, my part, my whole, and my percent. Okay. So I don't know what the percent is because that's what we're going to find. So I know I'm not given my percent, and so that'll be X. My whole, well, it'll be the 345 chips that I have. Okay. And the 27 that are underweight is the 27, is the part. Okay. Okay, like this. Okay. So now, with this decision made, I can now set up the relationship we're going to use to solve this problem. Right. We recall that the part over the whole is equal to the percent. And by the way, I know you guys are probably already getting tired of hearing me say it over and over and over again, but by repetition, it'll also be drilled into your brain. And so if you guys see a percent problem and you identify what the part, whole, and percent are, and you set it up like this, then you'll just automatically be able to set up the equation like I do here. So here my part is 27, right? So it's going to be 27 divided by my whole, which is 345, which will be equal to my percent. I don't know it, so I'm putting an X there, divided by 100. Okay? So once we're here, we can then start setting up this problem to solve it. I can see that if A over B equals C over D, then AD equals BC. And again, I know you guys are probably already sick and tired of hearing me say that over and over again, but again, this is about drilling you to solve these problems consistently, the same way, because the less changes there are, the more likely you're just going to be like machines doing it automatically. So 27 times 100 will equal to 345 times X. So 27 times 100 will equal to 345 times X. Okay. So now the question is, what is 27 times 100? So I'm going to do that here. So 27 times 100, okay, will equal to 7 times 0 is 0, 7 times 0 is 0, 7 times 1 is 7, 2 times 0 is 0, 2 times 0 is 0, 2 times 1 is 2. Then I just add 0 plus 0 is 0, 0 plus 0 is 0, 7 plus 0 is 7, 2, 2700. 2700 equals to 345x. Okay? Okay. So now, in order to finish this problem, we're going to have to perform this division. We're going to have to divide both sides by 345. Okay? Okay. So that's going to be x equals 2700 divided by 345. Okay. So now what I'm going to do is I'm going to perform this division here. I'm going to get to the fraction, and then I'm going to get to the decimal expansion so that you guys can see that. And so you can get a feel for doing these kinds of divisions. I know that some of these divisions may be intimidating because they have more than one number and stuff like that. And so I'm going to walk you through it slowly, making my complete. So let me shut up a moment. Okay. 345 goes into 2700. Okay, this is the division problem I want to accomplish. Now, in order to do this, I'm going to start by making a complete multiplication table for 345 off to one side. Okay. So let's make it here. N, and then here it'll be n times 345. So we already know that 1 times 345 will be 345. Okay? So how do I get the next one? So I'm going to add over and over again. So by the way, I know this might take a while for me to do this, but I want you to stick with me so that we can do it together, and so you can develop confidence that this is an effective technique, and then so we can use it to do the division in a relatively quick manner. Okay? So now I want to get 2 times 345. I could do that by multiplication if I wanted to. So yes, let's do that. 2 times 345 is going to be, well, no, okay, I'm just going to show you adding each time, okay, because that'll be easier. Okay, so 345, because that's this one, plus 345 will give us 5 plus 5 is 10, so 0, 1. 4 plus 4 is 8, plus 1 is 9. 3 plus 3 is 6. So 2 times 345 is 690. Now, to get the next term in my multiplication table, I'm going to take this value, 690, and I'm going to add 345. So I'm going to get 0 plus 5 is 5. 9 plus 4 is 13. Carry the 1. 1 plus 6 is 7. Plus 3 is 10. So it'll be 1035 for 3. Okay. So 1035 plus 345 will be 5 plus 5 is 10. Carry the 1. 1 plus 3 is 4. Plus 4 is 8. 0 plus 3 is 3. And then 1. So 1380. Okay. Then the next one will be 5. So it'll be 1380 plus 345. So 0 plus 5 is 5. 8 plus 4 is 12. Carry the 1. 1 plus 3 is 4. Plus 3 is 7. And then, 7. And then I just bring down the 1. So that's 1725. Okay. Okay. So now 1725 plus 345. Okay. 5 plus 5 is 10. I carry the 1. 1 plus 2 is 3. Plus 4 is 7. Okay. 7 plus 3 is 10. So I bring down the 0, carry the 1. 1 plus 1 is 2. So this will be 2070. That's times 6 times 7, 8, and 9. Okay. So here, 27 plus 345 will be 5. 7 plus 4 is 11. I'm going to bring down the 1, carry the 1. 1 plus 3 is 4. And then I bring down the 2. 2415. Now I promise you guys that having made this multiplication table, the division will come out super nice. And we'll be able to do, okay, and I'm going to shut up now. So I'm just going to do this final 2 additions to get my multiplication table done. So again, I'm adding 345 each time. 5 plus 5 is 0. It's 10. I carry the 1. 1 plus 1 is 2. Plus 4 is 6. 4 plus 3 is 7. And then I bring the 2. 2760. And then finally, I'm going to add 345 to that. And I get 0 plus 5 is 5. 6 plus 4 is 10. So I bring down the 0, carry the 1. 1 plus 7 is 8. 8 plus 3 is 11. So I bring down the 1, carry the 1. And that becomes 3. So 3105. Okay? Okay. So now look at this. I now have my complete multiplication table for 345. And I'm going to use it to do this division. Okay. So does 345 go into 2? Of course not. 27? Neither. 270? No. 2700? Aha, it does. We look at our table. 7 times. I put the digit over the number that I needed that I'm putting it inside of. I'm putting it inside of 2700, so I'm putting it at the end of that digit. Okay. Now 7 times 345. Because we did our table, we know that that's 2415. Okay. And so now I'm going to perform this subtraction. So 2700 minus 2415. Okay. Can I do 0 minus 5? No. So I have to borrow. But I can't borrow from here because this is a 0 also, so I have to borrow from here. So this is going to become a 6, okay? This is going to become a, this would have become a 10, but it's going to become a 9, and this is going to become a 10, okay? So actually, let me redo that here real quickly for you, okay? Okay. So 2700 minus 2415. Okay. So I want to take away 5 from 0, but I can't, right? Because 0 is less than 5. So I want to borrow from here, but there's nothing here. So I'm going to borrow from here. This is going to become 6, right? So that would make this a 10, right? So now I can ask, can I take away 5 from 0? I can't. But now this is no longer a 0, it's now a 10. So now I can borrow from here. This will become a 9, and then this will become a 10. So now finally, 10 minus 5 is 5. 9 minus 1 is 8. 6 minus 4 is 2. And 2 minus 2 is 0. Okay? So this will be 285. And look, if you are in any doubt, whenever you're doing a calculation at home, a subtraction, and you want to make sure you got the subtraction right, you can always add these two bottom numbers to see if you get the top number. I'm going to do that here just to verify it and just to show you that this is possible. Okay? So 5 plus 5 is 10. I bring down my 0. I carry my 1. 1 plus 1 is 2. Plus 8 is 10. I bring down my 0. I carry my 1. 1 plus 4 is 5, 6, 7. And then I bring down the 2, 2700. So in fact, we know we did it right. And moreover, we know that 285 is less than 345. There's nothing else to bring down. And so I can already write my x as 7 with the fractional part 285 over 345. Okay? And of course, this fraction can be simplified if I want to reduce, I can reduce it to lowest terms. But I'm not going to do that right now. Instead, what I'm going to do is I'm going to expand the decimal places a few, like maybe 2 or 3 decimal places, just to show you that we can do that and to give us some practice doing that. Okay, because some problems will require you to write it as a fraction, some problems will require you to write it as a decimal. Okay, so here again we have nothing else to bring it down, right? So what we have to do is we have to affix a decimal place. I like to use a different color so I can know the exact moment when I did this, and then I affix my 0, I bring it down, and now it becomes, instead of 285, it's 2850. And I ask, what's the biggest digit that I can multiply 345 by without exceeding 2850? And I can see it's 8. 8 times 345 is 2760. So it'll be 7.8. This will be 2760. And now I can perform this subtraction. Okay? So let me do that subtraction here. Okay? 2850 minus 2760. Okay? 0 minus 0, I can't do it. 5 minus 6, I can't do it. So I'm going to borrow. This is going to become a 7. This is going to become 15. Okay? I'm going to start counting from 6. 7, 8, 9, 10, 11. 12, 13, 14, 15. I had to go up 9 to get to 15. So 15 minus 6 is 9. Okay. 7 minus 7 is 0. 2 minus 2 is 0. Let me actually do that with my two hands, the subtraction there that I did. 15 minus 6, right? So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? Just so that there's no doubt there. 90. So I'm going to put that here. Okay? And then what I'm going to do is I'm going to affix a 0. Once I perform this subtraction, I affix a 0 and I bring it down as well. So now I'm going to ask the question again. How many times does 345 go into 900? Twice. Right? And that'll give us 690. Okay? Now I'm going to subtract these. Okay? So let me do that here real briefly here. I'll just do one more decimal place. Okay? Just so that we can see the thing happening. 900 minus 690. Okay? So I asked 0 minus 0. That's 0. 0 minus 9, I can't do it. So I'm going to borrow from this. This is going to become an 8, and this is going to become a 10. 10 minus 9, that's 1. 8 minus 6 is 2. So this is 210. And then once I perform that subtraction, I bring down another 0. I get 2100. I ask myself, how many times does 345 go into 2100? 6 times. And that's 2070. And then we can continue doing the decimal expansion. And so what that tells us is that this is going to be approximately 7.826. Yeah. So now, okay. So now we can answer the question at hand, okay? So they're telling us, while running the casino, an astute casino manager observed that out of 345 chips, 27 were found to be underweight. What percent of the chips were underweight? Well, in an exact, there were exactly 7 and 285 over 345% that were underweight. Or if we want to use the decimal expansion, approximately 7.826% of the chips were underweight. And right now, just for completeness, I'm going to simplify this fraction to lowest terms, okay? Yeah. Okay, so I want to simplify 285 divided by 345. Now, check this out. Since both the top number and the bottom number have a 5 at the end, they're both divisible by 5, and so that'll help us out. So I'm going to first divide 5 into 285 into the top. Okay? Okay. 5 goes into 2, it doesn't. 5 goes into 28 5 times, because 5 times 5 is 25. Then I do 28 minus 25. That's going to be 3, right? Because 8 minus 5 is 3, and then 2 minus 2 is 0. I'm going to bring down this 5, and I ask myself, 5 goes into 35. Aha! 7 times. So 7 times 5 is 35. 5 minus 5 is 0. 3 minus 3 is 0. So that's 0. So I'm going to replace the top with 57. And what about the bottom? So I'm going to divide 345 by 5. I ask myself, does 5 go into 3? It doesn't. Does 5 go into 34? Yes, it does. 6 times. 6 times 5 is 30. 34, 4 minus 0, that's 4. 3 minus 3, that's 0. So I bring down my 5. Okay. And I can ask, does 5 go into 45? Indeed it does. It goes 9 times. 9 times 5 is 45. And we can see that when I subtract that, I get 0. So I can simplify that to 57 over 69. Okay? And then, how do you call it? You can ask yourself, Does 2 divide the top or bottom? No. Well, does 2 divide the top and bottom? It doesn't. It doesn't divide the top because the top does not enter with an even number. And it doesn't divide the bottom for the same reason. Now, I'm about to tell you something that's a neat little factoid to have in your mind. It turns out that if you have numbers like this, and you add the digits, in this case 5 plus 7 is 12, and in this case 6 plus 9 is 15. If you add the digits and that sum is equal to some number that is divisible by 3, then it turns out that that number is itself divisible by 3. So what I noticed right now is that to simplify this further, what I can do is I can say, aha, 5 plus 7 is 12. Well, 12 is 4 times 3. So I know that 57 will be divisible by 3. 6 plus 9 is 15. 3 times 5 is 15. So I know that the sum, the 6 plus 9 is divisible by 3. So I know that both of these are divisible by 3. So I'm going to do that now to simplify this fraction further. So 3 goes into 57. 3 goes into 5 once. 1 times 3 is 3. 5 minus 3 is 2. I bring down my 7. Aha. 3 goes into 27 9 times. Now, what about the 69? 3 goes into 69. 3 goes into 6 twice. 2 times 3 is 6. 6 minus 6 is 0. I bring down my 9. 3 goes into 9 3 times, because 3 times 3 is 9. And therefore, when I subtract that, I get 0. So now I can replace this with 19 over 23. And it turns out that that's the least terms for this fraction. So now we can finally write this fraction, this number, the answer to our problem, in lowest terms as 7 and 19 over 23. Okay? So I can answer this question one more time by saying that out of the 345 chips, exactly 7 and 19 over 23% were underweight. Thank you.